Brandon, how do you use that to find the period?
You take 2 pi and then divide it by d, which would be the same thing as taking 2 pi over 1 times 12 over pi. The pi's would cancel out and then you'd be left with 24.
So your typical period, the distance from the start to the stop, or the distance around the unit circle, is 2 pi. That changes when there's a b value, so you're taking that 2 pi and dividing it by pi over 12. That's supposed to be 12. Or as Brandon said, really that means you're taking 2 pi and taking the reciprocal of this, so you're timing it by 12 over pi. Because when you divide by a fraction, you're really multiplying by its reciprocal. So the pi's cancel, and Brandon, that gives us a period of 24. So now it starts at 0 and it ends at 24. That should be the whole stretch of the graph. So technically this graph is huge, because usually we stop at 2 pi, which is about 6.28. This is going to 24. So it's really stretching very far. The last thing that you have to find is what to count by, because every graph could technically look the same. But we need to figure out what these little tick marks mean, or what the angles are that create those tick marks. And I call that the key point value, which we'll use again today. And Brandon, to find that key point value,
you take the period and divide it by 4.
Right, we always take the period and divide it by 4. There are multiple reasons why you divide it by 4. One, because there's 4 quadrants in the unit circle. The second is because 5 points create 4 intervals. I have 4 intervals between my 5 points if I start at 0. So there are always 4 equal intervals. Each is equal, because to get from 0 to 90, it's 90 degrees. That's an equal interval for the first quadrant in the unit circle. So everything should always be spaced equally. You should never have 2 points that are closer together and another 2 points that are further apart from each other. And then the last thing we have to think about would be kind of labeling the y-axis. Maybe I'll just count by 2's. So that's kind of like giving us a sketch. This is a guideline here. I haven't actually graphed, but we've kind of filled some things out to help us think about the graph. So then we want some points, and to get the points, we start at 0. I'm going to leave the y value out. We need 5 points. How do you find the second value? Alice?
So, wait, so the y value, okay, so the period divided by 4 would be 6. So you count by 6 each time, so that would be 6, the next one 12, 18, then 20.
Nice. So to get the key point value, you take the period, which is 24, divide it by 4, 6. That's what you count by to go from one angle to the next. So each one of these is an increment of 6. The last one is the period, because from start to stop, I now want that distance of 24 units. Alex.
So for the x values,
So if we're graphing sine, the typical x or y value would be what?
so it'd be 0, 1, 0, negative 1, and 0.
But because there's a negative 5 in front, they become
0, negative 5, 0, 5, 0.
nice job. So that's focusing first on x and getting all the x values using this number here. So the key point value is key to finding your ordered pairs. That's what you use to go from one next number to the next, one angle to the next. And then the y values, the numbers I have underneath are the standard y values, 0, 1, 0, negative 1, 0. But you need to multiply that by negative 5 because there's a negative 5 for the a value. So then you have all that information. We just need to plot some points. So this is counting by not 3, counting by 6. And the first point is at 0, 0. The second one goes all the way down to negative 5. Up to 0, all the way up to positive 5, back down to 0. So because of the negative, this should be the opposite graph for sine that we're typically used to seeing. Usually sine goes up and comes back down. Well, now it's doing the opposite. And then to continue it on the other side, like you just have to keep graphing. So I need to go back up, come down, all the way down, and then go back to the middle. So when you look at your graph, you should never have two peaks next to each other. You should always have a peak and then the bottom of the wave because it's gaining momentum to go back up and come back down. Questions? Hopefully that clarifies some things for some of you with the period. So the key point value is so important. We're going to use that same value today because that's what we need to calculate one angle to the next. And that's always your period cut in fourths. So I can use that same increment to go from one point to the next point, to the next point, to the next point. Questions? So today we're going to go through two more examples. Every day we've kind of worked on two examples. Tomorrow we'll do one final big problem together that has everything in it. And then hopefully you'll have some time to practice kind of working on some of the graphs. They get a little harder each day. Another letter that we're attaching. In your packet, it's page 9. At the top of page 9, talks about the general equation for sine and cosine, which is the basic equation without any numbers in it. You might want graph paper as well, just because it's so hard to see that little grid in your packet. But if you're fine making your own little grid, then feel free to use it, but I use a ton of graph paper, so you can just write the equation on the graph paper and use the graph paper. So at the top of page 9, we now have an extra letter added. So y equals a, the sine x, bx minus c in parentheses, or y equals a cosine bx minus c. And on the side of my board, I have a little reminder to get us to kind of think about what's going on with these graphs when you add that extra number in parentheses. And I just wrote the standard parabola equation that we used a lot last year and we used a lot this year. So the a in front of the parentheses with a parabola tells us that stretch. It also says the parabola opens up or the parabola opens down. But once you place a number inside with x, how does that move the graph? Virginia? Yeah, to the left or the right. So when it's inside, Virginia, if it's at x minus 3 squared, that graph would go to the right. But if it's at x plus 3 squared, the graph would go to the left. So it always does the opposite of what you think. That's the same for cosine and cosine. So the facts of graphing and where numbers are placed are the same thing for every single graph. So every graph shifts to the right even though it says a minus inside parentheses. It always does the opposite. So we're going to talk about the phase shift today, which literally is shifting the graph left or right. So we're now shifting it. Our starting point is no longer at 0, 0. Just like a parabola usually starts at 0, 0, and then you shift it to 3, you shift it to the negative 3. The way we're shifting that graph is by using the c in the parentheses, that third number, and also the b, because the period stretches it horizontally, and the c value helps us shift it horizontally. Well, both of those together give us our actual phase shift. So it's called a phase shift because it's a new start of a phase of the graph, of a cycle of a graph. So that phase shift is the number c divided by b. So it takes into account the value that's being added or subtracted, but also the period, because that's stretching it, and we have to make sure that stretch is attached to also the phase shift. So phase shift is the number c over b. So if you look at the first problem, this one starts out a little easier than the second. We're going to work through the same way that we just did the warm-up. So we're going to think of now a, b, and c, and what a, b, and c do to the graph. So if we start y equals 1/2 sine, and then in parentheses, x minus pi over 3. So usually this would say a sine bx minus c. So that's the standard form. Now we have the 3 letters. just starting with A. Eris, what number is A in the equation?
1/2.
1/2. So A is a half. The amplitude is also 1/2. That's the distance that we would go from the middle to the top of the wave. Okay, working in alphabetical order. What number is B? Brandon?
3.
Eris? Any other options? What number's with X? 1. So all of this represents C. The number in front of X, there's really a 1 there. So C is X over 3. That whole thing there is C. The B value is just 1, because the B value is whatever is sitting with X. Well, the number sitting with X is just 1. C is beyond that, behind that in the parentheses. So the B value is 1. That 1 helps us find the period. How do you find the period? Brandon?
2 pi divided
2 pi divided
by b
by b. Well, in this case, 2 pi divided by 1
is 2 pi.
is just 2 pi. This one has a standard period because the number with X is just 1. Brandon?
So c over b equals c. Technically. Because the phase shift is c over b.
What's C?
C is pi over 3.
Okay, so C is pi over 3. It's positive, even though it says a minus in the problem, it's the opposite. And then the phase shift, Brandon said, is C over B. Well, C is pi over 3 and B is 1. So yes, Brandon, in this problem, the phase shift C over B is pi over 3 because B is just 1.
Okay.
It could change if the B value is 2, if the B value is 3, if the B value is 4, if the B value is 5. Virginia.
There's an equation here on the page. What does it mean? It's like y equals b sine b x.
This right here?
Yeah.
So that's factoring the B out and thinking of that B as being separate from your X.
Why is it c over b?
Because if anytime you factor is, if you use GCF, factor is really dividing. So if you factor something, you're dividing that number out of the problem. So if you divide it out and stick it in front, that's how you get the C over B.
Makes sense.
Other questions? All right, so we have A, amplitude, B was 1, found the period. C is pi over 3, so we have the phase shift. If this is positive, we're shifting right. If that number is negative, we're shifting left. So because it's a pi over 3, my graph is now shifting to the right. Just like if it was x minus 3, our graph is shifting to the right. The last thing that we need to find in order for us to get from one angle to the next is the key point. And remember, that's the period divided by 4. Because that then gives me equal increments to go from one angle to the next angle to the next angle. And our period is 2 pi. We're dividing that by 4. So, Virginia, 2 pi divided by 4 is pi over 2. I'm going to circle this guy because that guy is important as well. So, everything I have right here, I really haven't graphed. Just kind of making sure we know what each piece represents in the problem. Question? So we're going to see if we can find those angles. So we have our 5 angles, 5 points to graph. Okay, so there's the 5 points for my graph. What is the first angle that we're starting with?
0.
Michael,
Pi over 3,
why is it pi over 3, Michael?
because you can shift right.
Right, we're shifting right. So this number right here, that phase shift, is where the graph shifts to begin. So no longer is it starting at 0 because we're shifting. When it was x minus 3, that graph starts at 3 because it shifted away from 0. So we're shifting to the value of pi over 3, and that's where the graph begins. That's our first x value. It's the first angle. Michael, do you know how you're going to find the next angle?
How would you add pi over 2?
Yeah, that key point value is how we find then every other angle. Typically we start at 0, but now we're starting somewhere else. So this is where it gets tricky, because now we have fractions with two different denominators. So we have our phase shift, but we have the increment that we're using to go from one point to the next, and that's pi over 2. Michael, what would the common denominator be?
6.
6. So this changes to a 6, that changes to a 2. This changes to a 6 and a 3. So pi over 2 is really 3 pi over 6. And then add those two together and that gives you your second angle. So 2 plus 3 makes 5 pi over 6. But we have to get 5 angles. So you need to take 5 pi over 6. What are you adding to it? Alex?
Pi over
Yeah, pi over 2. Well, if I want to keep a common denominator,
Oh, yeah.
that's all right. We're really adding 3 pi over 6. So Alice, 5 pi over 6 and 3 pi over 6 make 8 pi over 6. But reduced in the ordered pair would be,
4 pi over
there you go, 4 pi over 3. So a little tricky with those fractions. Again, we need to add 1/2 for pi over 2. So that's really 3 pi over 6. So 8 and 3 make 11 pi over 6. And then one more time because we have to have 5 points. 11 pi over 6 plus 3 pi over 6 makes 14 pi over 6 or 7 pi over 3.
So, since the key point is pi over, like, the period is 2 pi,
Mhm.
so would it just, like, you know, like, the last point on the unit circle, it would just be
Mhm.
all, like, going around,
Yes.
right? Okay.
Yes. So the period is still 2 pi. If I look at the distance between the first and the last point, 7 pi over 3 minus pi over 3 is 6 pi over 3, which is still 2 pi. So it still has that period, even though we're starting at a new place and ending at a new place. And we've also added pi over 2 4 times. So we've added that period to get to the end of the graph. Questions? Okay, here's the tricky part because now we have to try and graph this, and labeling the graph is a little difficult. When you look at your ordered pairs, oh wait, we didn't get the y value. Let's get y value and then we'll get the ordered pair, or we'll graph it. So this was sine, so sine starts with 0, 1, 0, -1, 0. But it says 1/2 in front, so it's going to be 0, 1/2, 0, -1/2, 0. Now we have the y value. I want to forget about y. Questions? So when you go to label the graph, we need to decide what each one of these little marks, each box on the graph represents. And we have two different fractions that we're working with, because we have pi over 3 versus pi over 6. Whatever your common denominator is, the least common denominator, is what each one of those tick marks needs to be, so that everything is still the same distance apart from each other. So what would the least common denominator be of your ordered pairs? Virginia? Pi over 6. So each unit on this graph, each one of the little boxes, is going to be pi over 6. So we're going to count by pi over 6 because that's the least common denominator, so that includes both the angles up here. So the first little tick mark, I know, it's weird, Brandon, right? I wanted a smaller pen. Oh, I have it as small as I can go. Shucks. All right. So the first little tick mark here, and I can't write any smaller than this. This represents pi over 6. That's what we're counting by. So then my second tick mark is 2 pi over 6, but 2 pi over 6 is really pi over 3. My third tick mark would be 3 pi over 6. I'm not going to label everything. The fourth one is 4 pi over 6, and then I'm at 5 pi over 6. That I'm labeling because that's one of my key points. So I'm just continuing to count. 6 pi over 6, 7 pi over 6, 8 pi over 6 is my third key point of 4 pi over 3. 9 pi over 6, 10 pi over 6, 11 pi over 6. I need to add a couple of extra. 12 pi over 6, 13 pi over 6, 14 pi over 6, which is 7 pi over 3. So I labeled the first one to show I was counting by pi over 6, and then the other values that are labeled are still the 5 points. And then we have to count up 4 to go to 1, down 4 to go to -1. So when you plot your points, you're starting at pi over 3, which is actually the second box. So I'm not starting at 0, because the graph starts at pi over 3 on the x-axis. So that's where your first point should be located. Not at pi over 6, not at 0, but at pi over 3. And then it goes up at a half at the 5 pi over 6, back at 0, down to -1/2, back at 0. So you should see now the shift in the graph because it's not starting at the origin. It's shifted to the right. Brandon, if you look at every single one of those points, how many spaces are between all of your points? 3. So every point is still equally spaced. So when you move in the other direction, Brandon, how many spaces need to be between every single one of your points?
7. 3.
So when I start at this point, my last point, which is really the first point, I need to go over 3 blocks. 1, 2, 3. That's where my next tick mark goes. Count over 1, 2, 3. Another tick mark. Another tick mark. Because when you graph the second half of the graph, you still need to make sure that the points are the same distance apart. You can't have one being like 2 spaces and one being 3 spaces and one being 4 spaces. So that still, when you look between one point and the next, you should still have the same number of spaces. So it goes down to -1/2, 0, up to +1/2, and then back down at 0. Because I should never have 2 peaks next to each other. I should have a peak and a valley, a peak and a valley, a peak and a valley. But I still have 3 points between these two, 3 spaces between those 2 points. It is okay that at 0 there's 2 spaces on one side but only 1 on the other. That's all right. It's the distance between the points that needs to stay equal. Questions with graphing that? A little more involved. So we're going to see if we can try and get the last one on this page graphed. Got about 7 minutes, so we'll see if we can work a little faster through it. So if you look at the last problem, we have -3 cosine 2 pi x plus 4 pi. So a lot of numbers in here. Let's kind of start with A, B, and C. Eris, A is -3. But our amplitude is a +3. A helps us create the graph, but the amplitude, the actual definition of an amplitude, is a positive stretch horizontally of the graph. Eris, B is?
2 pi.
Good. B helps us calculate the period, which is standard taking 2 pi, dividing it by B. Well, we're taking 2 pi divided by 2 pi, which is weird, but it's just the number 1. That's the period. 1. And then what's C? negative 4 pi. C is always the opposite of what's inside that equation because technically this is a minus negative 4 pi. So the phase shift is C divided by B. It's those two numbers. So C is negative 4 pi, B is 2 pi. So our phase shift is just negative 2. This is where our graph starts. So it's moving left instead of moving right because it's negative, so we're starting to the left. The last thing we have to get is the key point. And that's the period divided by 4. While our period is 1, we're dividing that by 4, so we're counting by a 4th. So the points are really close together. They're just a 4th apart from each other, 1/4. So starts at negative 2. See if you can continue to add 1/4 to go to the next value. So you're taking negative 2 plus a 4th. Negative 2 is really 8/4. So negative 8/4 plus 1/4. Your new angle plus 1/4. The new angle plus 1/4. What's the last angle that you should have? Negative 1. What's the distance between negative 2 and negative 1? 1. What's our period? 1.
That's how you know you did it right.
That's how you know you did it right. So the last thing we need to do is go back up and look at that A value of negative 3 and the fact that we're dealing with cosine. So cosine is 1, 0, negative 1, 0, 1. So that means if we have a negative 3, we're starting at negative 3, ending at negative 3. And then you've got all the information you need. You just have to decide what each one of those little tick marks represents on your graph. And that's your least common denominator. So when you look at your ordered pairs, the least common denominator is 1/4. So each one of these boxes represents 1/4, but we need to move left. So this is negative 1/4. That first box is negative 1/4. And then we have negative 2/4, negative 3/4, negative 4/4 is negative 1. Negative 5/4, negative 6/4. Negative 7/4, negative 8/4 is negative 2. So your points are no longer 3 spaces apart from each other because the period is so short and the distance between each point is so short. It's not always going to have 3 boxes in between every point anymore. So again, least common denominator is what every one of those tick marks are. Sometimes your graphs are just going to be really close together. So the last thing to graph at negative 2, we're down at negative 3. The next point is right next to that. They're only 1 space apart from each other. These are really close together. 3 over 2 is up at positive 3. The next line is down at 0, and then at negative 1, we're back down at negative 3. So those 5 points are so close together. And then just going up, coming back down, you end on the y-axis to have 2 periods. This is a really skinny graph. So you can kind of see how the period affects the graph, how the shift affects the graph. Now, we've graphed everything on the negative side of the graph. So there's 7 graphs that you have tonight. They'll be a little more tricky than the last couple of graphs that we've done. As I said, tomorrow we're going to do 1 graph together, a big one like this, a tricky one. And then we'll have some time in class to practice. Have an awesome day.
You too.